everyone. Today we are going to discuss about real analysis. Hope you will find no problem with the concepts of real numbers after going through this. The real number system consists of all the rational and irrational numbers. The real number system has many subsets. They are natural numbers, whole numbers, integers, rational numbers and irrational numbers. First one is natural numbers. Natural numbers are the set of counting numbers. Next one, whole numbers. Whole numbers are the set of numbers that include 0 plus the set of natural numbers. Next one is integers. Integers are the set of whole numbers and their opposites. Next one, rational numbers. Rational numbers are any numbers that can be expressed in the form of a divides b, where a and b are integers and b is not equal to 0. They can always be expressed by using terminating decimals or repeating decimals. Next one, irrational numbers. Irrational numbers are expressed as non-terminating, non-repeating decimals. Decimal that go on forever without repeating a pattern. Next we have a continuous function. A real function f is continuous if it is continuous at every point in the domain of f. We can explain this in detail with mathematical terms. Suppose f is a function defined on a closed interval a comma b, then for f to be continuous, it needs to be continuous at every point in closed interval a comma b, including the endpoints a and b. Continuity of f of x at a means limit x tends to a plus f of x equal to f of a, and continuity of f of x at b means limit x tends to b minus f of x equal to f of b. Thus, if f is defined only at one point, it is continuous there. That is, if the domain of f is a singleton, the function f will be a continuous function. Next, we see that derivatives. F of x is said to be differentiable at the point x equal to a if the derivative f dash of a exists at every point in its domain. It is given by f dash of a is equal to limit h tends to 0 f of a plus h minus f of a divided by h. For a function to be differentiable at any point x equal to a in its domain, it must be continuous at that particular point, but it is not always true. Next, we see that Lagrange's mean value theorem. Suppose f of x is a function that satisfies below conditions. F of x is continuous in closed interval a comma b, f of x is differentiable in open interval a comma b, then there exists a real number c such that c lies between a and b, and f of b minus f of a equal to f dash of c into b minus a. Mean value theorem is the relationship between the derivative of a function and decreasing or increasing nature of function. It basically defines the derivative of a differential and a continuous function. Next, we see that Riemann integral. The Riemann integral, developed by the mathematician Bernard Riemann, was the first accurate definition of the integral of a function and an interval. The real analysis is a very important and a vast branch of mathematics applied in higher studies. It was introduced for the study of the theory of functions for real variables. It deals with real variables, real numbers and real valued functions. We can also say that it studies analytic properties of sequences and real functions. It includes the study of limits and convergence of real number sequences. This analysis deals with continuity and other properties of real valued functions. It is also concerned with the calculus over real numbers. When an upper integral is equal to the lower integral, then it is called Riemann integral. Thank you.